So to write a calculator, but of course a simple one, right? Because the calculators can be complicated sometimes. So I actually don't think we've seen it, but I'm pretty sure I have not talked about. On HTML, you guys learn how to write comments, right?
Yes.
So on HTML, you would do something like this, right? That's a comment. So for instance, right now I only want to import the calculator JS. I don't want the JavaScript, so I'm commenting it out. Now in JavaScript, the comment syntax changes a little bit. It can either be // and I think on CSS was the same. I'm not sure. And this is a comment.
And I've read in the multi-line comment you start the
Yes.
star and slash.
Yeah, /*, and then there is actually two ways, and I'm gonna explain this. This is also a comment, and then you can have like multiple lines, whatever. But you can also just do it with one star. Oh, not that one. This one. You can also do it like this. The big difference is because, I mean, the thing is that this one, the first one, is more useful for the IDEs like VS Code, because it can help you a lot. If you have a function and then you want to type the comments of the functions, like saying, oh, the first parameter is to do this or that. Sometimes there are plugins that help you writing those things, so it's always better to use this one. But if you want to have some code here, it's better to use this one, because this one does not automatically put asterisk. This one puts every time you go. So then, yeah, it's a bit harder to remove the comment. That's, I think. I mean, both of them are valid. Some.
So which one's better to use? First one or second?
I use both. For me, it depends on the situation. For instance, let's say if I have a console log, right? And I want to remove this console log for now. Actually, I even use this one only the two. But if I actually have a function, it's badly written, but it's okay. In this case, honestly, this one would be better, because it's only 2 lines to remove. Because this one, as you can see, it auto-completed, and now it's a bit weird. But like everything in programming, that you can either do one way or the other, there is fights between developers. Developers cannot agree in things. That's the world we have right now. That's the world we cannot solve that problem. Developers cannot agree. Some of them say one is better, but there is no reason. Use whatever you feel it makes sense at the time. Yes, so these are the comments. Now actually let's use this comment to write the requirements of the calculator. And, so it should take in 3 arguments. The first argument should be the action. In this case would be sum, subtraction, multiplication, and division. Let's make a simple calculator, right? The last 2 arguments should be the numbers to execute the action. And it should return the result. Right. Would this make sense to be a calculator? for now. So in order to do this, of course, I calculator function, because it should be a function, right? So we can use it anywhere, basically. So of course, let's just start typing function. Let's call it calculator, actually. And yeah, right now it doesn't have anything. But again, for the sake of, and this again is personal, you don't have to do it if you don't like it, but if I'm starting to type something that I kind of know what's going to be, and there is this part here, it should return the result. So let's just return something so we don't forget about it. We can even return 0, why not? And now it says it should take in 3 arguments, but in a function, why is this parameters, right? So should we, and of course, we can have different ones, different type of arguments. So for instance, if we could define sum and multiplication and subtraction, but that would be a lot of arguments, right? So in this case, because we have, it can either be one or the other, or the other, or the other, then it's a condition, right? We could use conditions for these things. So let's just have something called action, actually, because then we can send in the action as a parameter saying sum, and then these 2 numbers, multiply these 2 numbers, divide these 2 numbers, or division. So we're going to have an action, and then number 1 and number 2. Okay, so now we could, let's first try to make the sum, even without, I don't know, anything else. Let's make the sum. So we can have a let result equals number 1 plus number 2. And then of course we should return the result. Now, one thing that I would also advise you to do is that instead of writing a lot of code and then start console log from the beginning. Again, this is far from being finished, right? But let's see what it gives us actually. So calculator, and then okay, the first one has to be an action. We don't really have actions yet, so we can actually send a empty, and then 1, and then 1. Now this, I don't think I mentioned it, but it's actually good, we are seeing it now. If we would do this, calculator 1 and 1, do you think this would work?
No, because you define 3 parameters and you should enter 3.
Exactly. Because in here we say we need the first argument parameter has to be action, second one is a number, third is another number. So in here, because we are only testing it for now to see if the sum even works, we need to send something in the first one. I mean, I'm sending an empty string, but it could actually be 0. It could be 100. It could be whatever. It could actually be undefined, even. Because this would work. And because the truth is that, and again, your IDE, your VS Code, or whatever tool you use to write your code, they help you a lot. They do help you a lot. If you look at our function, we can actually see this one is gray and these two are dark. And now let's see if we do this. Now number 2 is dark, it's gray. And the reason is like just by looking at the function here, we actually see like, oh, we are not using this one, and we are not using this one. We are using this one only inside of the function. And yes, there is no action, there is no number 2, there is no nothing. So, so that's a way that your VS Code can help you a lot with your coding. Sometimes you define some variables and you don't end up using them. It's not terribly bad, but it's bad because again, a browser needs memory to run. And if you define a lot of variables, those variables take up memory. So your website becomes slow. Slow websites are not good for people, as we all know. So yeah, the sum is working. And we are not even saying what type of action this is, right? But now let's send in an action. And again, I'm saying the word action because that was the name I gave to it. But let's use a string, right? Because that's a way of checking if it's something or something else as well. And just to make sure, let's actually see if it's even here. The action is action, and you see now action is actually dark again, so it's no longer grayed out because it's in used. Oh, it misses the log. So the action is sum. Okay, so now we have a sum. That's our code is working, right? But it's not a calculator yet. So let's try a subtraction. But in order to try subtraction, now we cannot delete the sum because we need to add things. And this is, to be honest, like the day-to-day work of a developer, honestly, is you usually are never the one creating the code. You always get the code from someone else that it already was in a company before you at some point, and you have to do changes to the code of someone else. And again, it's working as a team. Now imagine, and that would be a good exercise, but that could take too long. But imagine that instead of me doing the calculator, I would ask you to do the sum, you do the subtraction, you do the multiplication. But altogether, you have to work in one thing. So, for instance, someone has to do the sum first, and then give the code to the other to adapt to it. So, for instance, I cannot now I cannot change this because someone is dependent on the sum of this. Somewhere, someone is dependent on this. If I remove it, if I do a simple mistake, it can kill the website. I'm in big trouble, right? So, what we need to make sure is that the state of the code that we got needs to keep the same when we give it back. And by the same, it doesn't mean that it has to look the same. It just has to make the same features. So now let's change it a bit because we want to make sure that we can differentiate a sum from a subtraction. So we can use a condition, right? We can ask what's the action of this condition, and if it's sum, then we move, actually let's just move all the code inside of there. Now whoever did the sum, it's still working. We didn't ruin anyone else's code. Of course, if somebody was smart and is not sending any action, now their code won't work, but that was bad by design, so it's not our fault, right? We make sure that the sum still works. And we want to implement subtraction now, right? So let's just do it ourselves, and this is our part of the code now. Action, if it's a subtraction, then, well, we need to, oops, not null, minus number 2, right? And then let's return the result. But now, because we are like, oh, the guy who wrote the code before is still very new, he doesn't know that we can do this, right? Let's do it ourselves. And let's keep that because that's not our responsibility for now, right? We are only here to do the subtraction now. We don't care about the other people's code. Sometimes that will happen. So now subtraction, and this should be 0, right? I think. Okay, so there was an action sum and it was 2, action subtraction 0. Perfect. Everything is working fine. Now by looking at the code, you can think like it could be optimized, right? We could move this one here. But again, it doesn't have to, right? It still works fine. There's no errors. And I still kept whoever did this code intact. I didn't change it at all. And sometimes, again, this might happen when you work as a team, that someone else does a piece of code or a function that you might not agree with. You might be like, I would change that. And it's okay to change that, but it's also okay to leave that. Sometimes it's actually better to tell the other person like, oh, you know, you could do it differently next time, or I can do it differently if you accept. And because again, one of the very important things is to be able to collaborate and also teach each other on a day-to-day basis, of course.
Can you give us time to write it down?
Yes. Yes, but if...
I have already most of it. But
yeah, it's okay, it's okay. Actually, who's looking at the screen? Do I have anything wrong in there that I should maybe do?
The console log up the actions.
No, I actually have something missing. Maybe. It's because this ifs, I don't have anything else, right? This is a case that can and probably will happen.
You will add in the end.
Yes, always at the end of it.
Yeah. Because we still need the division and
Yes, of course. But because we are asking people to send us the action you want to do, we could, in this case, just do right? So for instance, like this, because we are asking the user to send in action, but honestly, we are saying here that it can be these ones, but that's a bit, the rules are not very strict, right? Because I can write whatever there, it's a string. So in this type of functions where we check for the input of the user, in this case, this is the argument of the user, we check for a specific value. But the last one, the last else, should always be a kind of double check to say like, hey, you're doing something wrong because we don't have any condition for whatever you're giving us. And yeah, this would be a way, of course, you could say like, oh, we only allow actions like sum, multiply, blah, blah, blah. You can write whatever message you feel like. But this would be a way of always return the last else, because that makes your code a bit vulnerable. It means that by the input, I can make your code fail, basically. And that's not a good thing to have in a if, else if, else if, else if. So for instance, if somebody would say this because they wrote sum and then maybe subtraction is just sub, right? Maybe. Of course, it tells us that sub is not allowed because it's not in, we don't have a condition for it, right? Yeah, should we try the multiplication? So now we have this else here that we should always keep, right? Because we know that we need to make our code a bit defensive from whatever people are asking us for. So let's just write. And I mean, again, sometimes things might be a bit ugly to start writing in the middle of the code, or you're not sure, am I writing in the correct place? But sometimes it might just be easier to actually copy and paste. Copy paste is the day-to-day base, so that's completely fine. So now, which one should we make? Multiplication, right? Yeah. Multiplication. Number 1 times number 2. Right, this works. Probably fine. Let's put something different, maybe. Again, for instance, if you ever have a task like this where the first step of the task might be a bit, am I doing things right or wrong? And as I say, you can always console log, you can always debug your code. But now it's like, I mean, we are what, 90% sure that this is correct, right? Because it's no different than the changes we did here. So in this case, I'll say it's okay, just keep going, keep doing stuff, and you don't have to debug, but because we are learning, let's do that, right? So now multiplication, and it gives us the number 4. Yeah, we added 2 times 2. Seems right. Which one is missing? Division.
There's a special button for debug. You use or tools for debug?
No. No, because again, if you run things on a browser and something is wrong, the browser will tell you where things are wrong. For instance, in here, we can say that this is wrong because there is an undefined here. And we see here, where is it? Calculator.js, oh, sorry. Calculator.js, and that means line number 35. So by clicking on it, we can see like, oh, in here, we get something wrong. So just using the browser is enough to either get the errors or get the correct answers, of course. So now, in order to make the division, let's just copy paste. So again, after, if you understand like how else if works and where the brackets actually go, and that might take some time to actually get used to it. If you just copy like that and paste it like here, it just goes fine. It just works. And now we have division and we have to divide here. Right. So now let's just have a look at it. If it's a sum, number 1 plus number 2, return. If it's a subtraction, return 1 minus 2. If it's a multiplication, return 1 times 2. And if it's a division, return 1 divided by 2. So I guess, and of course, if we don't understand whatever is on the action, if it's empty, if it's something that it's not defined here, then returns a small message to the user. Now, wait, let me just finish this division. Now let's divide 8 by 2. Now in here, and this would be actually a very good use case, we are console logging. And as we mentioned last week, console log is actually to see what's happening, is to log the result, to debug whatever is happening. But this is not really a log, right? Like if we reach here, we want the user to pay attention to the code, right? So we could actually use something called console.error. And now, as you see, it shows a little bit different. Now, if any user uses our function, they will see like, oh, this is a mistake. There is like a red error mistake, so it's something to pay attention on. And this is the perfect use case for an error. You could have a warning, and warning is a yellow. But again, warning, in my opinion, warning should be something that it is legal, but it's not okay.
Yeah.
Error is something that it's not legal and it's definitely not okay. So, and in this case, it's not okay to call a calculator with an action that we do not understand. So I would put an error, definitely. And yeah, our calculation as division, as multiplication. And now we can actually, we see ourselves in this situation of, yeah, but I mean, it is true that the user in here writes sum, it's a 3-letter word, right? And now, couldn't we also support this?
Yeah.
I mean,
of the action we send instead of yeah here.
Yeah, but we would like to support both, right? I mean, it would make sense to let the users
We can add and
or
oh
because if we add and, it has to be both.
yeah, exactly.
So in here we can actually say if the action is sub, then it's also okay. I mean, we can say it's a valid one. So now there is no error because now we are sending sub. And we can actually also say on this one, action equals to, is this okay? Mult, maybe. That's what people would write, I think. And this one, action equals division. But of course, we can still say some smart person can come here and say, oh, I want the power of 2, come on, 2 power of 2, right? Because they, I mean, some calculators allow this type of and now we say like, nope, we don't, we are a different calculator.
Marco,
Yeah.
I've done almost all things you did, but my VS Code showed an error exactly the place your
Here?
the blinking sign is, and for that else and open curly bracket, I had to delete it, then the error was gone.
Okay, can I see?
It was like here, right?
Mm-hmm.
It was here. Those and this, but this one was in and
Yeah, it misses an A. Yeah.
but that time I
Yeah.
had was
Yeah.
so maybe I
No. No, but that could also be because of one of the returns that could be returning outside of the. For instance, I'm not sure how it was, but let's say if this return would actually be outside or something, it could have told you like, oh, it never reaches that else. It could be something like that.
Could be, but when you just click on the arrow, it just show you where is the problem.
Yeah.
So it just showed the else, but I think maybe I forgot to write this E or
Yeah.
I didn't type it. Because it works now,
Yeah.
but that time it didn't. And it was blue. It was purple. Pink.
Okay.
Yeah, I think it's
Yeah, that could be like either a typing mistake or something like that. Yeah. But actually, we can still change things around here, right? We can make it a little bit different.
Yeah.
For instance, as I said before, it would be good to have a return always at the end, something, right? So why not just returning result at the end? And now, yes, now we are going to mess up the whole code, and we need to make sure that all those if else still works. And again, this is the regular, like this is the real case of how you would do things for a project. Is you get this function and there is a error somewhere. Let's say that this one was not really divided, like it was, I don't know, summing, and the result is wrong, so we need to change this. But now you're like, yeah, but I don't like the code in here, so I want to change it, and it's completely fine. Again, as long as it doesn't lose the functionality of it. So, and we want a return at the end, right? So for instance, this we don't need here, so let's just comment it out. We can keep it for future reference. And let's actually have a result always. And I mean, in mathematics, 0 is where basically everything starts, kind of, right? So if nothing happens, we can assume it's 0, right? And so then let's return it here. We return the result. Now we really didn't make any big changes, right? Now the only one that actually will reach here is this guy, because all these have return. So, and again, I'm not sure if I mentioned that, but and I said like JavaScript starts running and it goes all the way, right? But in this case, we call here this function, so it goes up here and it starts running. Logs, now it's counted out, result equals 0, action is sum. Yes, it is, goes inside of it. Result now equals number 1 plus number 2, return result. It stops. It goes all the way back here because it has a return. It completely ignores whatever comes here. So it never reaches this guy, basically. And the same for subtraction. So subtraction comes in, is it? Nope. Is this one? Yep. Return. Stops execution, doesn't go here. The same for all the other ones. The last one, the one where we do not support, the power, let's say, come here, power, no, 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 no. Well, yeah, because it's the only one missing, and then it returns down here. So now, what we could do, instead of returning every time there is something, we return. We could actually use this result variable to, if it's a sum, now we need to remove this actually, but if it's a sum, we assign the sum to the result. If it's whatever, and then we return the result, right? We can do that. So let's just try to do it. So now, of course, that we just need to put result equals something instead of the return, because we no longer want to return. And result equals something. Now, oh yeah, we commented out that, I mean, it is safe to assume that nothing should change in terms of execution or logic. Now in here comes a big question of, do you prefer this one or the other one? Returning every time or returning at the end?
At the, because now we missed the else. So within nothing.
No, it will always get to this one. This one, it will always return, definitely. But we are not specifying return. We just, after going through all the stuff, then we return whatever we have. If we don't have anything, we return 0, right? We will always return something. Now, in my opinion, I prefer this.
Yes.
Because if I need to make some changes to names, whatever, I'm not messing up the return value. I hope I'm not messing up the return value. The one problem that some people would argue is memory, of course. Because before, it would never, if it would be sum, like the best case scenario is to be sum, right? Gets the first line, it's sum, return, I'm done.
Yes.
Right now, it won't be done. Right now, goes from here all the way back here. And yes, it is not executing this, but it can be considered memory. But again, this is, in my opinion, more clear and more. Again, we have the return at the end. We make sure that things are all the way down there, and it always returns something. Even if we want, for some reason, the result to start at 1, now it will always at least return 1, but these ones will still return their specific value. Nothing will change on those ones. No, but this one returns 1 for some reason. Yeah. And yeah, and in this tiny calculator, we used functions that we learned. We use conditions, the operators, most of them. We could also have used the percentage, the module of course. We just have to create another if. We also use these conditions here, if it's either one or the other, because we want to, I mean, let's just add it here as well, why not? Action equal. Is there another word for sum? No. Addition? Is that another word for sum?
Yeah.
Kind of.
Yeah.
Just to make sure that we have more than a word for each action.
Also, we can add the simple star.
Yes. That is true. We can even say if the action actually is equal to that itself. Right?
Yeah.
So we could actually say this, but we have to send it as a string. We cannot send it like this, because that's an operator. Still works, still supports it, and of course we can make it as complicated as we want, or as simple, depending on the perspective, as we want. And yes, and we used most of the things we learned today. Yes, let's just have a look here, just to figure out. So yeah, this part, these two parts, conditions and functions, and calling the function parameters, it's something that can easily be achieved by building a calculator. Yeah. Is there any questions related to this exact exercise? No. Awesome. Now, let's have a small look into global versus local scope. We saw it already. Maybe we did not use those exact words, but let's see. So okay, this was the calculator. So now I will just comment this one out as well. It will still be here. Oh shit. Come on. And let's have another one. I'll use a loop. And now I should create a file here. Okay, so now we are in a different file. Global scope. The global scope is not really part of the loop thing. It's just that I can use the same file for both topics, but the global scope was what we mentioned about the variables. So, for instance, I'll use the name global variable just to represent it. And now we have a function, and this would be an inner function. And now in here we can say console log global variable, and let's just call the function inner function. So now this should print out too, right? Yeah, it does. Now in here we can have a const local variable or no, let's have it local. It prints out local, everything is fine. So now what about out here? Oh, it's not assert. Yeah, now we have an error. And again, we talked about this a little bit before. So out here, we have a global variable. And again, I named it global on purpose to represent. And when we print it here, this one works fine. And then down here we call a function. Actually, we should have called the function before, sorry about that. Yeah, or else we won't really see the correct error. Yes, exactly. So yeah, we have this variable, we define this function, now we don't really care about the code. Then in here we call the function, so whatever happens inside should be called. Then we are logging this global variable, which we define there. Then we are logging this local variable, which we define here. Here, sorry. Now, the problem is, this variable is available because we define it all the way up here at the root of our file, of our code. But this one, the first time we ever say this variable is something, was inside of this function. So it does not, this variable cannot exist outside of this function unless we define it again. So even for instance, if we would return local variable, we could not still use the name local variable because that name is not defined anywhere in our code, in our outside code. And that's basically what the error is telling us. It's telling us that this variable is not defined at all. I don't know what you're talking about. And yeah, and that is the again, if we can actually do this, local variable equals 2. Now this will work, and local variable as a complete different value now, even though the name is the same, but it's because we are using it outside of the function. Now inside of this function, if we do this, now this one that we are printing out here, in here, now as the value 100, because it gets it from here and it completely ignores whatever was outside. Again, we should use functions to do something with the numbers or strings we give to them. We should not allow them to manipulate whatever is outside of them unless we give it to it. Unless in here we say global variable. But again, this global variable is sent as a parameter, not it's not this global variable, it's a different global variable. Because that might, again, that might attack you from behind and you have zero idea what's happening when your code starts failing, because you might be manipulating things inside of a function that does not exist. In other programming languages, there are ways of actually passing value, and then the function passes the same value changed back. In JavaScript, I would, let's say you have an array of names and you want to add something to each name of the array. So you make a function for it. And you send in the array, but then you should always return also an array. Not exactly the same, because it's going to be changed, but do not change whatever is out here and then assume that, yeah, someone else will take care of it. Because, yeah, the local and global scope is something a bit tricky. So again, as we said before, make the functions responsible for their own thing. Because again, if now I copy this into this file, it won't work because nobody knows what this is. It's not defined anywhere. Yeah.
As Marco said, global or local variables, let's take, but I want to teach you something. I consider this is the whole file scope. And here, this is the scope for the function. It's inside the scope of file. Consider there is an eye here. You can see the inner eye can see the outer variable. But the opposite, it's not right. And, as we are in this room, we can see what it's outside the room. But the outside of the room of the building cannot see what's inside. You can write instruction or statement here, can see the variables outside. But the outside cannot see
What's inside? Yeah.
And also there is another trick, because the code executing from the top down, if we put another variable here, this is code.
Yeah.
You can see it or not?
What comes after? No.
No. Just what's come after, just before.
Yeah, because it's from top down.
Up
Yeah.
from down. But the most tricky thing, the inner can see the bigger, or the outer cannot see what is
Yeah.
the inner.
Yeah, and again, that's one of the reasons why you should not manipulate things outside, because then if you need to manipulate it again, might be that the values are no longer the same, or yeah, it becomes very, 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 very tricky. Okay, so now we still have time. Let's talk about loop. And a loop, do you know what a loop is? That's well, this is only fit in Denmark, is fitness club, so no. A loop is something that goes around, right? Goes around and around and around and around. And there is something in JavaScript, for looped. So, and again, for loop, for the ones who know other programming languages, this exists everywhere. In every single programming language, this exists. And it's a way of moving the code, moving not the code, but the execution, the variable, whatever you are using, to another step. Yeah. So usually, not usually, always, for loops are used for arrays. And again, because a string can be an array, also for strings, right? So
Or sometimes use it for range. You give, I don't know, for the exists in the JavaScript. You have a range, like for example, from 0 to 10.
yeah. If you want to create, for instance, values or something, you can put like from 1 to 10. I want to print out all the numbers.
Yeah.
And actually, let's use that now, just to see it working. So, for instance, we want to print out the first 10 numbers, right? Well, we can do this, right? But that takes time, and that's manual. We want the machine to do it for us. So we can do. And I'm going to explain. Okay, let me just make a console log somewhere here. So that we know where it started. Okay, so it started there. Right, from 0 to 9. So now, this, I'm going to scroll a little bit now, yeah. This word for is a keyword, again, and as you see, it's blue or wherever ID you're using might show in different colors depending. But yeah, this for is what starts a loop, basically. And in order to start a loop, you need to tell it from where to where should I do it, and how many steps should I give. So, I mean, it's kind of like a game, basically, when you think about it. So in here I'm saying, and I'm using the variable e. It's one of the most used variables for this because it's called index. The index of an array. So e is the index, but you can call it whatever you want, if it makes sense for you. And I'm starting at position 0. So I'm saying you start from 0. And that's the first. This is not really parameters, because parameters are separated by comma. In the for loop is semicolon, always. So this is a special, it's not a function. It's not really a function or anything. So I cannot call it parameters because that can confuse functions. I cannot call it arguments because that can confuse functions. But each section of a for loop has its own thing. The first one is where do I start? The second one is where do I stop? And the third one is how many steps should I give? So in here is a variable definition that we already learned. We say e equals 0, and of course it has to be a variable, it cannot be a constant, because we want it to move, right? Then in here we learn about the comparison. So we wanted to stop when it's 10. And again, here is where it's tricky, because it stops at 9, because we told them to start at 0. And it stops when it's smaller than 10. So if we want to stop exactly at 10, we need smaller or equal to 10. And then e++, as we saw before, it grabs whatever value we have here, and then it sums 1 to it. And it does that. And then inside of this function, in quotes, we can use this value. And we know that this is going to be like something is going to happen all these times, the combination of those times. So for instance, and when I studied programming, I never seen this working in a computer until I understood it in a piece of paper. That was our teacher was a bit crazy. I programmed in paper. I could never see it working, basically. And it was really hard to understand. Because, yes, it's about iterations. So, first iteration, we are on value 0. We need to go until 10. We are not there yet, so whatever, who cares? And then we're going to sum up 1. Cool, but that's not happening before I do whatever is inside. This happens when I'm done with, like, in between here. So in here, I'm going to print out 0. That's step 1. Then it goes inside again, and again, and again, until it meets this condition. Once it meets this condition, I'm done. And then it continues whatever code we will have after. Now, as you can see, this is a very easy way to either go through an array or generate things. So, for instance, if we first, let's just, I don't know, define an array here. In the first value, yep, let's go with that.
Yeah.
Second, third, and fourth, right?
Yeah.
I'm actually going to put this up here so we have it as a reference, and I'm going to write a new one. And again, I'm going to use the I because it's an index, and I like that one. Equals 0. Now in here, we want to print out each name individually in a console log, each step of the array. So now, I mean, by looking at it, we know it's an array of dimension 3 because it starts at 0, so it's 4, right?
Yes.
But we also know that there is the length function, right? So we can actually say dot length. We know that this gives us how big the array is. And now, oops, not this one, e++. And now, in order to print out a specific value of an array, we usually give the array and then the key, for instance, 0, 1, 2. So in this case, because we know that this one starts at 0, we do this. So now we have all those names printed as a string and no longer as an array. For instance, oh, come on. No longer like this. So we can, I don't know, if you have a list of users that you want to print them out specifically, you should use a for loop to do that, and you no longer have to print stuff like this.
How does this work? The length is 4, and we start from 0. So we have
wait, yeah, let's
length -1.
Let's see that. So our length here is 4, and yes, it starts at 0. Well, this is the magic of JavaScript, basically, because there is no value there. It does not even throw an undefined or anything. But yeah, what you're mentioning is this. No, actually, no, sorry, that was actually wrong. For instance, if we do this, as you see, let's remove here. So if we start at 1, actually starting in the position 1, and it's actually this ++1 that you actually don't have to calculate the length plus the real length to do it. By starting in this at 0, this one will actually not be executed in the last step. So the value will be 0, 1, 2, and 3. The 4 will never reach, basically. That's why, like, this is index 0. For instance, if we come on, log. Let's just print out the index together with it. So 0, 1, 2, and 3. It doesn't reach the 4.
Yeah. The condition is less than.
Yeah.
Less than or equal to.
So it would equal to reach.
Oh yeah. If you do this, then the last one will be undefined. Yes.
Yeah.
Yes.
Exactly.
Because yeah.
We want to jump to a step. Can we write like I plus equal to?
Yeah.
Fibonacci.
Yeah. For instance.
We can jump.
Yeah. You can let's just not console, const other array. Actually, let's do something else. I don't like to write arrays, so yeah, let other array equals array. And this was mentioned on the documents, but I don't think I explained it. It was mentioned on a start reading or something like that. But let's actually feed numbers into an array. So we start at 0. We want until 10. Why do I always put that? E++. Other array. And now here. And then once we have this array filled out, then we will jump twice just to see, or we'll see how it's going to work. So now down here, this is our array. It's empty. And now our array has 11 numbers inside. So this is a way of actually, if you need data, of creating data very, very easily. Because it's not only to read, it's also to generate stuff. So for instance, we start an array completely empty, and we go through 11 times, counting with the 0, and then we push those numbers inside, one by one. Again, like strings and like math, the array has a lot of functions. And the most common ones to use is push, which is to put stuff into an array. This would also, actually I missed this, this would also be valid. For instance, actually we could do this. So we could say, because the array is empty, right? So now we could say, oh, on the position, the first step of the for loop, it's 0. We are I is 0. So you can say, like, on the position 0, put 0. Then on the position 1, put 1. On the position 2, put 2. So that could also be a way of generating data into an array, or if we want, let's just do this, for instance, for now. Yeah, as you can see, it would be the push. Honestly, I would prefer to use the push always. It's a bit more fluent. This one, it's tricky. Don't might be tricky, but it is a possible way to do. So now we have an array with. Let's remove the 0. Let's start in 1. Okay, so it's from 1 to 10. We have this array here. Now, cannot focus. Let's equal 0. Other array dot length and other array of I. So now in here we actually told it to go every second instead of going every step, goes every 2 steps. And yeah, this would be a way of writing, which should be E equals E plus 2. So E equals I equals the value that it had before plus 2. So yeah, we had this array from 1 to 10, and now we can see that it prints every second, prints the number 1, then number 3, because it starts at 1. It starts at 0, and the first value is a 1. So yeah, this is a way. Of course, we can say, what about going every 5? Yeah, there's only 2 in this range. So yeah, this is again, sometimes in order to make some algorithm calculations, whatever, this could be used. I cannot really find an example right now, but yeah, it's something that can be clearly used. And yeah, and again, this is for loops. there is, and is there questions about for loops? How they work? I mean, we can use them to read arrays. We can, yes, use them to read strings. Let's try that. Name equals I'm just gonna copy this. Oops. So I had a string with my name, and now it just prints a console log of each single position of that string, including the space, of course. So again, because strings can be considered arrays in JavaScript, you can do something like this as well. So not only arrays, but also strings. Now, if we have time, we do. There is another type of loop, while. And the concept of while is similar to for, but not really. So actually, while it's a bit dangerous because it can create an infinite loop. So, and that's dangerous in terms of memory. The memory of the browser can go crazy. So, for instance, the syntax of while is just while, and then something, and it's a condition, that's something. So this condition can be true, and this is the dangerous part.
Yeah, this
So, and we can try to see how it happens, what happens. So now this, yeah, as you can see, it's printing that amount of times. Like it will never stop until the memory runs out. So that's a dangerous thing to do. I mean, whiles are very useful for a lot of situations. Yeah, now my browser is a bit tired of it. Come on. I made it on purpose, so yeah. Whiles can also be used, for instance, to read an array. So, for instance, let's say we had this other array that has a bunch of numbers inside. So we can say while this dot length smaller than no, sorry. Let e let e equals 0, and now while e less than dot length, and then e plus plus inside. Okay, this just decided to go nuts. That's why you should never do a while loop. Come on. Okay. That is open now. Does it open? Come on. Well, we can still do console log other way of e. No. Okay, maybe I need to open it again. Yes. Okay. So yeah, this gave us exactly the same result as the one up here. So I'll just put it there, and then I'll try to explain a little bit. Let's remove this. So similar in quotes, because it is a bit different to the for. loop of we need to put a start, we need to put an end, and we need to say how many steps is what happens here. We put the start outside here, we say where it stops. So basically this is, I mean, it's clear English is while this happens, do whatever is inside here. So yeah, this can be used for all sorts of situations of, again, printing out all the names inside of an array, calculating an array, something like that. Yeah.
Usually we use for loop when we know the number of steps that we use. And also we use while when we don't know exactly the number of steps. It's depending on the condition in the here of the while, and we should put some statements make us every steps be a closer from this to break this condition, or will be run forever. But this is the most used for when we use for or while. If we want, we know the number of steps that we should execute. We use for. We use while to make it repeated until this condition is blocked.
Oh yeah, true. Sorry. So, for instance, one, where did it went? Why is it not console logging? Oh, it's thinking. Okay. But yeah, one of the use cases, for instance, of a loop would really to be you have an array of numbers, like a bunch of values, and you want to sum all of them. Again, as you could imagine, that could be a function for that, but actually I don't think there is in JavaScript. I honestly don't know, but I don't think there is. So basically you have to go through the array. And I would actually not use a while, I would use a for. You could go through the array of numbers, and for instance, the one we had up here. And instead, of course, of printing this, you just need to have a value somewhere outside. Let's actually see it in action. Why is this still completely broken? Let's use a for loop instead. Yeah. 0. Yeah. The sum of the first 10 numbers is 55. And this, again, it's a very good tool to make operations like this. Again, if you ever have to make some code for statistics, for whatever, most of the times, whenever people have numbers on a database, it's in like a huge amount of numbers, in huge arrays of data, whatever. So yeah, it's a way of going through the array. And again, here we're using that operator that we learned, so it's whatever total is plus whatever value we get here. So this is a very simple way of summing all the first X numbers. Because as you learn up there, we cannot see here, we can actually create an array as big as we want, so we can easily make a function that calculates all, the sum of the first million numbers. If you try that, it can happen that your browser gets slow because again, it's a lot of calculations. It's, I mean, it is a powerful thing, but again, that's basically what a lot of programming is used for, is to calculate stuff. That was the reason why people invented programming in the first place, anyway. So yeah, and again, you can, if of course you're curious, you can question yourselves with the exercises of, like, for instance, this one of summing the first X amount of numbers, something like that. You're gonna have something for homework anyway, but if you have the time for it, this is I see it as a very cool thing to do. But yeah. And this is the loops, and I think we are done, right?